Hello, I thought I'd do you a video to show you our topic today. So the last lesson you were learning about how power stations worked and how they generated electricity. Well, the next stage is what happens to that electricity once it's been generated. And the short answer is it gets to the plug sockets that we use every day. But to get there, it has to travel along a series of wires. Now, at one point, Sidmouth would have had its own power station, so when you plugged your socket in, you would have got electricity that was generated in Sidmouth. But that wasn't a particularly useful way of getting your electricity, because if there was a problem, if there was a fault in the generator in Sidmouth, then nobody in Sidmouth would have got electricity, and you wouldn't have got electricity until it was fixed. So, in the UK, we have a system called the National Grid, and the National Grid joins up all the power stations by a series of cables. And you've probably seen the cables as you've been driving around the country and seen them. And it means that the electricity you're getting out of the plug socket might have come from Scotland, or even as far away as France, because we buy electricity from France if we need it, and we sell it to France as well. So that system of wires and cables is called the National Grid, and this is my National Grid demonstration to show you what we've got. So I'm going to switch it on, and hopefully you can see that I'm producing about 5 volts in my power station. And it's being transferred along wires, and there's 2 sets of wires. So let's look at the one at the front first of all. So I'm producing 5 volts here. The electricity is travelling down the cable to my home, which is the light bulb here, and actually I'm only getting 1 volt out of it. So where has that missing 4 volts gone? Well, it's gone in heating up this wire. In electricity, when we come back to school, you're going to learn about electrical resistance, and you've done a little bit of that at Key Stage 3. But the wires are getting heated up, and that means that we're losing 80% of our voltage just by heating up the wire. Now, if you're the electricity company that's making that electricity, 80% lost, only 20% efficient, isn't going to be particularly good. So this way isn't great. And if you think about it, we're transferring this electricity over hundreds of miles sometimes. So have a look at the back. We're still getting about 5 volts of electricity, but this time we've got a light bulb which is bright, and hopefully you can see we've got about 3 volts of electricity being generated. So it's about 60% efficient now. The difference is these 2 boxes here. They're called transformers, and inside a transformer is a iron metal lump, a core we call it, and wrapped around it are pieces of wires. And in year 11 you'll learn a little bit more about how transformers work. But this transforms the electricity into a higher voltage. I'm going to show you that by switching off the power supply, and I'm going to connect my wires to the middle. So when the power station makes their energy, they will make it at a voltage, and then they will transform it into a much larger voltage. And hopefully you can see now on this one that the voltage we've got is 51.8. Okay, 51.8, 50 volts of electricity. So we've transformed it, we've increased it by a factor of 10. Now, in the actual National Grid, we might transform the voltage up to as high as 500,000 volts. And we use that to transfer it across large distances. And then at the other end, we need to transform it back down, because 500,000 volts isn't going to be safe or sensible to have in your home. So we transform it back down, and that's what's happened here. I've transformed it from 5 to 50, and then at the other end I transform it back down to a value of about 3 volts. And that way much less energy is lost. The higher the voltage, the smaller the current, and you're going to learn about that using the equation power equals current times voltage. So the higher the voltage, the smaller the current, and therefore less energy is lost in heating. And that's the national grid. So next time you go outside and see those pylons, they're not just there to make the environment look different. They're there for a really useful purpose. And it means that when you're buying your electricity, you are getting as much as possible and as little as possible is being wasted. So now you know a little bit about the national grid, you can go on and complete the next task.